So a lot of this is, or should be, hopefully a little bit of review from whenever you were probably in some sort of pre-algebra class, maybe an Algebra 1, something like that. But again, a lot of this should be a little bit of common knowledge and should be a lot of review. So whenever we have probability, okay, probability of an event is a number between 0 and 1 that indicates how likely this event is going to happen. Okay, so whenever we have probability of an event, okay, you have basically where your probability is 0, where it's not going to happen. You have the other end where the event is definitely going to happen. And then you have the very middle, which is where it's basically half or 0.5, whatever you want to call it, okay, where it's equally likely to happen or not happen. Now, obviously, depending on what type of event we're talking about, or scenario, or situation, okay, is going to, and it's going to fall everywhere in between them. It may be like 1 over 8. It may be 1 over 6. It may be 12 over 13. I don't know, depending on what you have. Okay, depending on what you're dealing with as far as your event is concerned. Probability basically can be expressed as a fraction, a decimal, or as a percent. It all means the same thing. Normally, whenever I write it, I will write this as a fraction, because I will always put the percent or the number of times that it can happen over the number of times that are possible. Okay, 3 over 4 is the same thing as 0.75, which is the same thing as 75%. All of them mean the same thing. A few rules that you have. It says, what's the probability of rolling a 7 when a single die is rolled? What's the chance of that happening? 0. Don't look at me like I've got a third eye on my forehead. It's a trick question. Why is it 0? There's not a 7 on a 6-sided die. Okay? It's not going to happen. You guarantee that it's not going to happen. If it is a normal die, 6-sided, 7 can't come up if you only roll 1. Now, if you roll 2, yeah, you can have a 7. What's the probability or what's the chance of you rolling a number less than 7 whenever you roll a die? Every time, right? 6 out of 6, 100% of the time, 1. Depending on how you want to look at it, it all means the same thing. Okay? Now, every other number is basically in between there. Okay? If we're talking about 1 through 6. Bless you. Okay, so that brings us to what's called theoretical probability. Theoretical probability is when all outcomes are equally likely. Okay? Theoretical is going off of, this is what should happen. Okay? Not that it's always going to happen. Any sort of sporting event, okay, whatever you have, theoretically, one team can win, the other team can win. Theoretically, it's 50-50. Now, realistically, okay, or what we call experimentally, when we'll talk about it in a second, okay, it's not 50-50. Okay? You can play 100 times and the same team can win every single time. Theoretically, the other team's got a chance. 50-50. Okay? Theoretically, it could rain every day or it could not rain every day. Theoretically, there's a 50-50 chance that it can rain. Now, we know other things are likely because of how weather patterns and things like that work and stuff like that. Theoretically, before last year, a 16 seed in the basketball tournament could beat a 1 seed. That had never happened before except for last year. Okay? So the experimental probability went up maybe 0.1%. Okay? So whenever we write theoretical probability, we talk about the number of times that it's possible over the total possibilities that we have. Flipping a coin, rolling a dice, drawing a card, drawing a marble out of a bag, whatever. Going on Halloween and the chance of you getting a Snicker bar instead of a Baby Ruth or a Three Musketeers. Okay? It's all theoretical depending on what's in there or what you have or what you're dealing with. Okay? You can do it, you can figure out what the probability of this is to happen without actually having to go with flipping a coin 100 times. You may flip a coin 100 times. It's not necessarily going to land 50 times on heads, 50 times on tails. That's what we say that should happen, but that's not necessarily always going to happen. It's going to be really close to 50%, but it's not always the case. Okay? Equally likely events have the same probability of occurring, essentially. So it says a spinner has 8 equal sectors, numbered from 1 to 8. What's the probability of you getting a 6? 1 through 8 on the board. What's the chance? 1 out of 8, right? There's 1 6 on the board. So the chance of you getting a 6 is 1 over 8, or 0.125, or if you say 12.5%, all means the same thing. The second one then says spinning a number greater than 5. So what's the chance of a number greater than 5? Doesn't have to be 5, but greater than 5. 3 over 8, right? Because how many are above 5? 6, 7, 8. Okay, so there are 3 numbers that are bigger than 5, so 3 over 8, or 0.375, 37.5%, whatever. The one thing I will tell you, or that I want, if you write it as a percent, do not round it. If you have to round it, then go to the fraction. Same way with the decimal. I don't want to see 0.38. I don't want to see 38%. I want to see 37.5. I want to see 12.5. Then it says, what's the probability of drawing a club from a deck of cards? How many clubs are there in a deck of cards? 13. How many total cards are there? 52. So there are 13 clubs, 52 cards in the deck. It'll reduce to 1 over 4, or 0.25, or 25%. Experimental, what you've dealt with for the most part pretty well all your life, is theoretical probability. Now, experimental is when you actually perform an experiment, or you conduct a survey, or you look at a history of events. Okay? If I look at a number 16 seed in the NCAA basketball tournament going against the number 1 seed, the probability of that happening before last year was 0. Because it had never happened. Now it's 1 out of however many games they've played. However many times that's happened. Okay? Outcomes are not equally likely to occur because it relies on experience or experiment to determine outcomes. Okay? You look at previous data, or you look at current data, or whatever you're doing. You don't just say, well, this is what should happen. You actually test it out and see what happens. Okay? I could have one table flip a coin 100 times, another one flip 100 times, and their probability of it occurring may be more than half, it may be less than half, it may be right at 1/2 of the time. Okay? Essentially, like we've said, you look at the data to find the probability. So it says ninth graders must enroll in one math class. Enrollment of ninth grade students during the previous year is shown in the bar graph. Find the probability that a random chosen, so they just walk the halls and you say, hey, what math class are you in? The chance of them either being in Algebra 1 or Intro to Algebra. Now, obviously, these are classes that we don't have, but you get the idea. First off, you need to know how many total students do we have, or how can I find that? Add up 87, 36, 69, and 51, right? So before I do anything, I need to add up how many total students I'm dealing with, okay, or how many freshmen I'm dealing with, and 243 freshmen, right, if I add everything up. Now, it's Algebra 1 or Intro to Algebra. So what do I need to do with Algebra 1 and Intro to Algebra? Huh? I need to add those two numbers up. Right? So whenever I do that, if I have Algebra 1 or Intro to Algebra, I need to add those two values up. I get 138 over 243, so about about 0.568. Okay, if you do round, you need to put don't put an equal sign, put the little squiggly line, so then we can go from there. So about 56.8%. Not, hey, it is 58 or 56.8%. So if I walk the halls, and if these are the 4 classes that we offered, I had a little over 50% chance of that happening. What am I going to do then for the consumer math? What value am I going to take? 36 out of 243. So then about, about 0.148 or about 14.8%. Now, the last one then deals with geometric probability. Geometric probability can be found by calculating a ratio of 2 lengths, 2 areas, 2 volumes, whatever I'm talking about. Now, the one thing you don't have the picture that it's talking about, it's basically the area wanted over the total area. So, and again, you don't have this picture, and for whatever reason it didn't print, and I apologize. You go back. There. Same thing, she's got to fit soccer ball in that goal. Now, without the goalie, obviously that would be probably a little bit easier. But it's still, it's not as easy as it looks, right? Because, watch the best people in the world, watch Messi and Ronaldo and everything, and they still hit it up high and tight or kick it out, whatever. Okay? Still see some of the best pitchers in the game, still can't throw strikes sometimes. Okay? Even though you think, that target's huge. Okay? How many of you have played darts? Thrown darts? Really? You guys need to get out more. Okay? Just saying. Okay? There's this thing, on a dartboard, and this isn't a dartboard, but it's pretty close. Okay? You have a bullseye. You've got to hit it in the middle there. Okay? Looks easy, right? Not necessarily. Okay? Looks like, whoo, it's big, huge. Okay? So it says your dart is equally likely to hit any point inside the square board. You're like, man, Lots, I could hit that red one every single time. Bet you can't. So it says, what's the chance if you are equally, are you more likely to get a 10 point or a 0? 0's out here on the edge. Now, you may think, man, I'm good. I can hit that middle part every single time. Eddie probably says every time he's out there on the bump, man, I'm going to throw strikes every single time. Okay? Until what happens? Crap hits the fan and it's, we got 4 people on base and, Just walking everybody in. Okay? At least you know it can't happen. So then what's your chance of getting a 10? Okay? What's your area of this red circle? How do you find area of a circle? You should have learned this last year in your geometry class. Pi r squared. So pi r squared. So the area of that red circle divided by the total area of the square. So the square, how do you find the area of a square? 18 squared, right? Or 18 times 18. So again, we're going to go kind of about, like this is what it's going to be. So the area of the circle, pi r squared, over the side squared, we're looking at about 0.087. Okay? You've got less than a 10% chance of hitting that bullseye. Now, the picture's not really to scale, so the red bullseye is a lot bigger than what it should be. Okay? Because 3 inches here is a lot different than 3 inches the rest of the way out. Okay? It's not drawn to scale. Yes, ma'am?
Can I use the restroom?
Yes, you can. So then, what's the chance of you hitting the outside part where it's 0? The outside part where you don't hit anything within the circle. What do you think you need to do? What are you going to... Okay, subtract what? The whole big circle, right? So you're still going to have to find the area of the whole big circle, the blue, the yellow, the red, everything, from the total area. So in this case, what I'm going to have to do is I'm going to have to take the area of the square, which we already have, which is 18 squared, and I need to subtract the area of the big circle. So the red, the yellow, and the blue. So 9 pi squared, or 9 squared pi, right? So I do that. I have a about 21.5% chance of hitting the outside, the wings, basically, of my square, as opposed to the middle part of my circle. Now, why does it seem like it's harder to hit the outside, the yellow part, the pale white, yellow, whatever color we're calling that? Why does it seem harder to hit those 4 spots than hit that one spot right in the middle? Well, why does it look smaller? The area of all the light yellow or white, whatever color we're calling this, is more than the red area. How come it seems like it's so much harder?
It's not all together.
It's not all together. Okay? Everything's really condensed. Why does it always look like, hey man, that bullseye looks easy to hit? Why? Because it's all together. Okay? It's not split up into 4 groups. Now, if I said, hey, each corner, what's the chance of you trying to hit each corner? Okay? When Eddie's pitching, he's not trying to hit that dot right in the middle, are you? Because what happens? You're getting rubberneck because you're looking backwards, right? Where's he trying to hit? Corners. Okay? Hamline, whenever she's making 2 goals against Park Hill South and winning 3-0 yesterday, right? I get all that right? Okay. I didn't get critiqued on that one. That's good. Okay? You're not trying to hit right down the middle, are you? No, we're going upper 90s, right? Lower 90s. Look at my soccer skills and talking. And it's like I watch the World Cup once every 4 years. Every 2, I guess, because of the women's. And we dominate that. Oh.